the Department of Electronics and Communication Engineering. Today I am going to explain you about the subject Digital Signal Processing. In this, the first unit is Introduction to DSP. In this, today I will explain you about three different topics. The first one is classification of signals, the second topic is elements of DSP, and the third topic is advantages of DSP. Before going to this topics, first of all I want to explain you what is signal. Signal means it is one kind of physical quantity in which we will give some information which is a function of one or more than one independent variables. So it is considered as signal. The first topic is classification of signal. Now if we classify the signal, there are various types of signal. The first type is analog or digital signal. The second type is continuous time signal or discrete time signal. The third type is even signal or odd signal. Even signal is also considered as symmetrical signal, and odd signal we consider as anti-symmetrical signal. Now the next type is periodic or non-periodic signal. Next type is energy or power signal, and the last type is deterministic or random signal. Now if we define the first signal type, then the first type is analog signal. Now what is analog signal? Analog signal means it is a signal which has infinite number of amplitude levels, and it is known as analog signal. So if we define the analog signal means it is a signal which has infinite number of amplitude levels. If we bring the analog signal, it will look like this. From this diagram, you can see that it has infinite number of amplitude level. So if it has infinite number of amplitude level, then it will consider as analog signal, and if the amplitude levels are finite, then it will consider as digital signal. So if we are defining the digital signal, it will define as the signal which has finite number of amplitude level. Now from this diagram, you can see that the number of amplitude levels are finite. From this diagram, we can calculate the number of levels which are, this one is the first level, second, third, fourth, fifth. So there will be 5 different levels. So from this diagram, we can say that the number of amplitude levels are countable, so it will consider as finite number of amplitude level, and so it is considered as digital signal. Now the next type of signal is continuous time signal. Now what is continuous time signal? Continuous time signal means if the signal has finite amplitude level at each and every instant of time, then it is known as continuous time signal. So if we bring the continuous time signal, it will look like this. From this diagram, you can see that at each and every time instant, it has some finite value of amplitude level. So it is considered as continuous time signal. Now the next type of signal is discrete time signal. Now what is the meaning of discrete time signal? Discrete time signal can be defined as a signal which has finite amplitude levels at a particular instant of time only, when it is known as discrete time signal. From this diagram, you can see that this amplitude level is finite, but it is only particular instant of time only, otherwise its value equals to 0. So this particular signal can be defined as a discrete time signal. It means it has some finite amplitude level at particular instant of time only. Now the next type of signal is even or symmetrical signal. Now what is the meaning of even signal? Even signal means it is one kind of signal which has the symmetry over the y-axis. So if we are taking from the y-axis for positive term and for negative term, the signal will remain same. So it will be symmetrical on y-axis. So the signal is said to be even signal if it satisfies the following condition. Now what is the condition? X of t will be same as x of minus t. It means if we are taking positive part or negative part, on the both part the signal will remain same. So it is mirror image on the y-axis, so it is considered as even or symmetrical signal. So if we are doing the even signal, it will look like this. From this diagram, you can say that the positive part as well as the negative part will remain same. So from y-axis, if we will hold in the signal, then it will be same. It means it is a mirror image for positive and negative parts. It is considered as even signal. So Now the next type of signal is odd signal or anti-symmetrical signal. Now what is odd signal or anti-symmetrical signal? Odd signal means a signal x of t taken to be odd or anti-symmetrical signal if it satisfies the following condition. Now what is the condition? X of t equals to minus of minus x of minus. It means if it satisfies this condition, then and then only it is considered as odd signal. So from this we can say that from the y-axis, the positive part if it will be in the positive age increasing term, then in the negative side it will be in the decreasing form. So this type of signal is considered as odd signal. So from this diagram you can see that if we drawing this diagram, from the diagram you can say that the positive part, the signal will be in the positive term, and for negative cycle it will be in the decreasing form. So from this diagram you can see that this signal is anti-symmetrical or odd signal, because in the positive part it will goes on the plus sign, means it will be plus, and negative, for negative it will be minus minus plus, so it will be in the negative or decreasing form. Now the next type of signal is periodic signal. Now what is periodic signal? Periodic signal means it is one kind of signal which will repeat over a finite duration. So it will, but after particular time duration, it will be in the repeating form, or it will be after fixed time duration, it will be repeats for the entire range. So it will consider as periodic signal. So the periodic signal can be defined as a signal which repeats itself after some fixed time duration, then it is known as periodic. And if it will not repeat for the full range or it will not repeat at all, then it is known as non-periodic or aperiodic signal. So if we are doing the periodic signal, from this diagram you can see that periodic signal means it will be in the repeating form, and from this diagram you can see that this term in the repeating form will be considered as periodic signal. Now the next type of signal is non-periodic or aperiodic signal. As I told you that non-periodic signal means if it will not repeating over the entire range or does not repeat at all, then it is known as non-periodic signal. So if we define the signal which does not repeat itself after a fixed time duration or does not repeat at all, then it is known as non-periodic signal. And if we doing the signal, it will look like this. It will not repeat after a fixed time duration or not repeating form, so it is known as non-periodic signal. Now the next type of signal is energy signal. Now what is energy signal? Energy signal means it is one kind of signal which has total normalized energy is finite and non-zero. It means if we finding the energy of any signal, it will be in between 0 to infinite, then it is known as energy signal. And if the power of the signal will be in between 0 to infinite, then it is known as power signal. So energy signal can be defined like this. Energy signal having a finite non-zero energy, total normalized energy, then it is known as energy signal, and energy of the signal will be in between 0 to infinite. Similarly, for the power signal, power will be in between 0 to infinite, then it is known as power signal. Now the next type of signal is deterministic signal. Now what is deterministic signal? Deterministic signal means it is one kind of signal which we can determine by any method, by using graphical method, by using mathematical integration method, or by any lookup table method, or any well-defined rule, then it is known as deterministic signal. So if we are defining the deterministic signal, a signal which can be determined by a mathematical equation, lookup table, or some well-defined rule, then it is known as deterministic signal. And if we are drawing the deterministic signal, it will look like this. Suppose if I am drawing this diagram, from this diagram you can say that this is the diagram for the sine wave. So from this diagram we can say that the behavior of the signal will be like sine wave. So this is the sine signal. So if the behavior of the signal can be determined by any method, from this graph you can determine the behavior of the signal, right? So it is considered as deterministic. Suppose if I am writing that x of t equals to a sin omega t. So by using the equation also we can determine which type of signal is there, then it is also considered as deterministic signal. And the behavior of the signal cannot be determined by any method, then it is known as random signal. So the last type is random signal. It has unpredictable behavior of the signal, like if we taking the is considered as the random signal, so its behavior will be random in nature. So these are the types of the signal. Now the next topic is elements of digital signal processing. So suppose if you want to define how many elements which are occurring in the process of digital signal processing. So basically the digital signal processing has the first basic building block is digital signal processor, in which we will doing some different process on the digital signal. So which type of process we will done on this digital signal process? So basically we will add signal or multiply the signal, or we can convert the signal, we will check the similarity between the signal, or we can filter out the signal. So this type of processing can be done on this digital signal processor. So basic building block of the digital signal processing is the digital signal processing. Now if we see in the real world, the signal may be in terms of analog. Suppose like if I am taking the our information, like suppose if I am taking this communication, if I am talking something, then it is also one kind of signal. So this is, if we taking this is as the input signal, then this signal will be in terms of analog. And if you want to do some processing by this digital signal processor, then we have to first of all we have to convert this analog signal into the digital form, and then we will doing some process on it. So before applying the signal to the digital signal processor, first of all we have to convert analog signal into the digital signal. So for that we will use analog to digital converter. So basically it will convert the analog signal into digital, then it will apply it to the digital signal processor. So it will do the processing on it. But analog signal can't do the conversion in the digital directly. So for that, first of all we have to do the another process, which is sampling. Now for that we will use sample and hold circuit. What is the function of sample and hold circuit? Its function is it will convert the original continuous time signal into the discrete time signal by taking samples. So it will take a sample on a particular instant of time, then it will hold that sample up to the next arrival of the sample, then it will apply it to the output. So it will be considered as sample and hold circuit. Output of it will be given to this analog to digital converter to convert this analog signal into the digital one. But if you are using the sampling, then in the sampling there will be overlapping is occur. If you are using the sampling rate, so if it will occur in this sampling rate reduction, then it will give the aliasing error. So if you want to remove the aliasing error, so for that we have to use a filter. This filter is considered as anti-aliasing filter. So before applying the original information signal directly to the sample and hold circuit, we have to use anti-aliasing filter. So we will apply the original information signal to this anti-aliasing filter, and output of this anti-aliasing filter is given to this sample and hold circuit. So basically we are applying this analog input to this anti-aliasing filter, which will remove the high noise, high frequency noise or aliasing error. So it will remove this non-linearity, then it will giving to the signal to the sample and hold circuit. Then output of it is given to this analog to digital converter, and output of it is in the form of digital. So it will apply to this digital signal processing. So it will giving you the output which is processed version of the original signal. Now this output of this digital signal processor is in the form of digital, but our original information signal is in the form of analog. So we have to convert this digital signal into analog by using the digital to analog converter. So output of this digital signal processor is given to this digital to analog converter. So it will convert this digital signal into analog form, and output of it will be given to the reconstruction filter if there will be noise is occurring in reconstruction of the signal. So output of this DSP is given to the reconstruction filter, and it will give you output, which is the output signal which you require. So basic elements of the digital signal processor are the six one. First one is analog line converter, sample and hold circuit, A to D converter, digital signal processor, D to A converter, and the reconstruction filter. Now the next topic is advantages of digital over analog signal processing. So what are the advantages of digital signal processing over the analog signal processing? The first advantage is versatility. Now what is the meaning of versatility? Versatility means if we are designing only one hardware, like suppose if I am taking one digital signal processor chip, then we can use this chip in the different hardware. So it will be versatile in different hardware. So by using only one chip, we can use the different hardware, and because of that, it will design the different applications that we consider as versatile. So it is more versatile compared to the analog signal processing, because in the analog signal processing for the different applications, we have to design the different hardware. But this will be not happening in this digital signal processor. So this one is the advantage of the digital signal processing. Now the next advantage is repeatability. Now what is the meaning of repeatability? We can easily duplicate the design which we have implemented. So because of this duplication, we can use this duplicated version in any another application also. So this is the next advantage of digital signal processing. Now the next advantage is simplicity. It is simple in design because we are not using the separate resistor, inductor and capacitor, just we are using single chip to implement any application. So it is advantages. Now the next advantage is accuracy. As I told you that we are not using the resistor, inductor and capacitor. So because of that, there will be no change on the from the environment. So if we consider the environmental changes, then resistor, because of that, resistor, inductor and capacitor, it may be changed because it has some tolerance. But as we are not using resistor, inductor and capacitors in this digital signal processing, so it will not change in the output of the any system. So it will give you the accurate output. Now the next advantage is remote processing. So how it will be advantageous? So if we design any analog signal processing circuit, we can't store that circuit output in any device directly, but it will be stored in the digital signal processor, as we can store the data of digital signal process output on the magnetic tape or any drives or any disk. So at the remote location also we want to do the processing, then it can be possible in the digital signal processing. Now the next advantage is implementation of algorithms, as we are using the software along with hardware. So if we changing the software, so by using algorithms we can change the software or program, and then we can change the output. So easily we can implement different algorithms which are get the different output. So this can be possible in the digital signal processing. Now the next advantage is easy upgradation. As I told you that we are using the software, so because of that we can easily upgrade the system because we have to just change the software. There is no need to change in the hardware. Now the next advantage is compatibility. Now what is the meaning of compatibility? If we are designing any one circuit for the digital signal processing, we can also use this in the many applications. So it will be compatible to all the other hardware also. So there will be more compatibility compared to the analog signal processing in the digital signal processing. Now the next and last advantage of this system is cheaper. So in many applications we have to just use this single chip to design the different applications. So by using one chip we can design the different applications. There is no need to change all the design circuit like in the analog signal processing. So this is also one kind of advantage over the analog signal processing. Thank you so much.